Hello, and a big welcome back to all my subscribers. And if you're not a subscriber, why not? What's wrong with you? Right, I have another update on my M68K project. It's going better. Still not completely working, but it's better than it was. Let me just show you where I'm at. So, I ordered 4 more of these things, so I've got a new pin that all works fine. As somebody suggested in the comments, I have this 3D printed thing for repairing phone cases and stuff. It works really well at just going under here and levering this up without breaking the pins. So that was a very good suggestion. Thank you very much for that. I have progressed quite a bit. It doesn't actually do anything, well, much more than it did before. You turn it on and it sort of just really does nothing, but it is. I had previously a lot of issues with bus errors and some other things. That is now fixed. And the reason I was having bus errors was because of DTAC. Now, let me just show you what I did here. The DTAC thing has to be working. So you get lots of errors if it isn't doing what it's supposed to do. So that means the DTAC needs to be so DTAC on the CPU is active low, right? So the active low DTAC means that it needs to be pulled low when it's when the peripheral device like the RAM or ROM is ready to communicate, and it's high the rest of the time. So what I did was, in order to fix this, I used the AS, which is the address strobe, and that is also active low. And then I used the chip enable, which is also active low, but for the ROM and for the RAM. Now, last one I showed you how I had done that with some NAND gates. This time I've had to use more NAND gates, and the way that I've done this is not when the address strobe, not the address strobe, and not the chip enable. Feed that into a NAND gate, and then this will only go low if both. This will only be, this will come out low if both of these are a 1, or in other words, both the address strobe and the chip enable is active. Now this feeds into a resistor, which my drawings are pretty abysmal, but there you go. It feeds into a resistor, and then from that resistor it goes into the base of an NPN transistor. So it feeds into the base, and then this goes, the emitter goes to ground, and the collector through another resistor into VCC, and the VCC is also connected directly into the DTAC. So basically the upshot of this is when this goes low, it goes into the base, and it will pull the current through the collector down to the emitter, and basically it pulls DTAC low. The rest of the time it's no current, and therefore the DTAC is just high. So it's inactive high and active low. So when it gets pulled to ground, it becomes active and it's ready to go. So I've done that with 2 NPN transistors for both of the chip enables for the ROM and chip enable for the RAM, and that all appears to work. And now my problem seems to be with memory addressing. Now I believe this is still a wiring problem. I think I still have something wrong, either a loose wire or something not connected properly or whatever, but I believe the control signals are all okay. I mean, I've got one problem, which is I've only got this single channel oscilloscope. It's just a cheap, single channel oscilloscope, and I don't have a logic analyzer. Now, in order to debug this properly, I'm going to need to do one or two things, or possibly both, and that is to get myself a better, at least 2-channel oscilloscope, and or a logic analyzer. Now, I'm told I can do a poor man's logic analyzer with an Arduino. Now, that is something that I am not lacking of. I have lots of Arduinos and a fair few amount of Raspberry Pis as well, if I needed to use those. But I've got a lot of Arduino kit, and I'm told that I would be able to build a poor man's logic analyzer. Now, somebody's going to send me over the how to make a logic analyzer with an Arduino. So this should be 6-channel analyzer, and then I'll be able to see the signals. I need to monitor the DTAC, the AS. I need to look at the chip enables for the ROM and the RAM. I would like to keep monitoring the bus error. There's a lot of control signals that I want to look at as I'm doing this, but I mean it doesn't look very spectacular. You turn it on and it just goes to the memory address at the top. It doesn't seem to be doing a lot, but it is actually doing things. It's just not doing the thing I wanted it to do. So if I plug in my logic probe, I mean, again, the having a logic probe helps, but it doesn't help me a great deal. But if you look, if we just take this address line, actually it's flashing really quickly. So on an oscilloscope I would see this, and when I did it, it worked out to about 2 megahertz. So I have an 8 megahertz clock, and it's working at about 2 megahertz, that it's just flipping back and forth. So it is doing stuff, but it's not doing the right stuff, and I need to figure out what it is doing. The chip enable in this example with the ROM is high, which means it's inactive, and it's also high on the RAM. So it's not actually accessing the RAM or the ROM, but it doesn't have a bus error either. So all kinds of weirdness going on. I don't really have the equipment to hand to do the diagnostic stuff that I need yet. But the DTAC thing is working. I can see it working, and I'm really quite happy with that. So, that's where I am this week. Hopefully more progress next week. If nothing else, you might get to see a poor man's logic analyzer in use. So that's it for me. If you like these sort of videos, again, please like and subscribe and all that sort of YouTube stuff. And I'll see you later. Thanks a lot. Bye.